In this video, we'll discuss the applications of linear functions in business and economics. Now let's start with some key equations that can help us around revenue, costs, and profits. One of the most common ones you'll see is that P of x equals R of x minus C of x. So what do these terms mean? This means that the profit will be equal to the revenue minus the costs, all in terms of how many units are sold. That's what the x represents. So these are three different functions. So when we're trying to calculate the revenue function, that's going to be equal to our marginal profit times the number of units sold. And marginal profit is like our slope. It's telling us the profit for each unit that's sold. When we think about the cost function, this is going to be our marginal costs times the number of units sold plus any fixed costs that may be associated with the production. And again, the marginal costs in this case, those are the costs to produce each unit. That's like our slope for this equation. And then to determine if we ever want to break even, that's when our profit equals $0. So if we think about this equation, we could say that 0 equals the revenue minus the costs, or we could say that the revenue has to equal the costs, and that's when everything breaks even. Now it's a lot of different words and formulas. Let's apply them to see what this means in context with a problem. So say we have a company that manufactures and sells calculators for $75 each, and the production costs them $5,225 each month plus $20 for each calculator produced. So let's create the function for each, the revenue, the cost, and the profit. Let's start with the revenue. The revenue is how much money are we making on the calculators. In this case, we're told we're making $75 for each calculator. We don't know how many are being sold, so we want to keep this with a variable for that each calculator. That's why we say that the revenue in terms of x is equal to $75 times x. The costs then are how much it costs for each calculator to be produced plus any fixed costs. So in this case, it's $20 for each calculator to be created, and then a monthly fixed amount of $5,225. So there becomes our cost function. Then to determine the profit, our profit is how much revenue we make minus any cost that we incur. Now we can take our two expressions and substitute them in, but when we do this, remember to distribute the negative to both the 20x and the $5,225. This means that what we end up with the profit actually being equal to is $55 times x minus the $5,225. Now the other pieces that were talked about initially were the marginal profit, costs, and fixed costs. The marginal profit represents the slope on our revenue function. So just to reiterate, that revenue function was 75x. So we're looking at the slope, which is the $75. That means each unit is going to make $75. When we talk about the marginal costs, we need to use our cost function, and it represents the slope on the cost function. That's the 20x, or $20 to produce each calculator. And then our fixed costs represent the y-intercept on this cost function. Those are fixed. That's what's added on automatically. In this case, that's the $5,225. Now, what if you were asked to determine the profits on 200 units being sold? So that's what this P of 200 means. It's saying substitute in 200 for our x value in the profit function. So just to reiterate, that was the revenue minus the costs, and we simplified that already to 55x minus $5,225. So I'm going to substitute in 200 for my x value and then simplify my expression. So this becomes $11,000 minus $5,225. That gives us a profit of $5,775. And that's positive, which means it was a profit. So if 200 calculators are sold, the company will earn $5,775. Now, the last question that we could relate back to our original equations was the idea of breaking even. When we break even, that means that our profit is equal to 0. or you could say the revenue has to equal the costs. So if we substitute in 0 for our profit in that expression, we can then solve this for the number of units. So I'm going to add 5,225 to both sides, and then I'm going to divide both sides by 55, and that's going to give me that X is 95. That means that for the company to break even, they must sell 95 calculators each month. Now, other concepts that come up in business and economics is the idea of supply, demand, and equilibrium. And we can use linear functions to help us with this as well. Just in a very broad sense, supply represents the availability of a product. Demand will represent the amount of that product being desired. And then we have to recognize that the price of the product is going to impact both the supply and demand. So what we often see is often a linear function where quantity is represented on the x-axis and price is represented on the y-axis. So you often see Q for x and P for y. Now what happens is that when I graph them, that as my price increases, my demand will decrease, and as my price increases, my supply often increases as well. The key here is recognizing that we have a shortage when there's a greater demand for the quantity than the supplied quantity. So if something's in high demand but it's not out there, that's a shortage. Whereas it's a surplus if there's lots of an object out there, but there's not a lot of demand for that quantity. Now what we're often trying to do, and companies are specifically trying to do, is reach an equilibrium. That's the price and the quantity produced that meets both the supply and demand for that product. And that happens at the intersection of those two functions. So that's really that sweet spot for a lot of companies, is trying to reach equilibrium. So how do we do that? Often you're going to be given a supply and a demand function. And as you saw, they graphed and they will intersect. And think about, how do we solve two lines that intersect? Well, that's a system of equations. So we can graph it, we can use substitution, or we can use elimination. Whichever of those three methods is the easiest for the given problem. So let's look at an example here. Say a company is selling coats, determines that their supply function is 5p minus 2q equals 290, and their demand function is 4p plus 3q equals 600. And they want to know, if the company sells their coats for $66, will there be a surplus or a shortage of coats? So to do this, what we would do is say we have a price here, and we want to figure out, where's our quantity greater? Is the quantity greater in the supply or in the demand? So let's substitute 66 into each and solve for the quantity. So on the supply side, that would be 5 times the $66 minus 2q equals 290. I'm going to simplify the 5 times 66 to $330. I subtract 330 from both sides. That'll leave me with negative 2q equals negative 40. If I divide both sides by negative 2, that tells me the quantity would be 20 when the price is $66 for the supply. Now let's look and compare that with the demand. In the demand side, if the price is $66, that would simplify to 264 plus 3q equals 600. I subtract the 264 from both, and that will leave me with 3q equals 336. When I divide both sides by 3, that tells me that my demand would be for 112 coats at this price of $66. Now look, the demand quantity is greater than the supply quantity because it's not probably great for the company to make them at this low of a price. This means that since there's a greater demand, there would be a shortage. Now what would that look like if you graphed it? Here are those 2 points. On the supply side, it'd be at 2066. The demand side, 112.66. And you can see this is further to the right, which means that that demand is higher than that supply. So then the question comes in, at what point will the two meet both the supply and demand? In other words, when can we reach equilibrium? Now we can do this again one of 3 ways. So let's graph those lines. And as I said earlier, P is often substituted for Y, and Q is substituted for X whenever we graph supply and demand functions. So we're going to make sure it's going to replace the x and the y in P and Q in our equations and then rewrite them for y so we can graph the two lines. So our supply equation, I've substituted in, and now I'm going to add 2x to both sides, and then I'm going to divide all three terms by 5. So this becomes y equals 2/5 x plus 58. That's my supply equation. Now I take my demand equation. I'm going to take 4y plus 3x equals 600, subtract 3x from both sides, and divide by 4. And that simplifies to y equals negative 3/4 x plus 150. I have two lines. I have their slope and their y-intercept, so I graph them. And I look and say, where do they intersect? They intersect at this point 80, 90. Well, what does that mean? That means that if each coat is sold for $90, then 80 coats will be sold, and that will meet both the supply and the demand expectations.